Hi everyone, welcome to NCCAP. Today in our video we are going to cover Radix Sort as part of data structures and algorithms. So first we'll see what is Radix Sort, what is its algorithm and how it works, and we'll see the sample implementation of this algorithm using Java programming language. So first we'll see what is Radix Sort. So Radix Sort is a linear sorting algorithm. So it is very efficient for the integers, and we can also use it for the strings. So what we are going to do here, it is we'll do digit by digit sorting, which is going to start from the least significant digit to the most significant digit. So it is going to sort based on the digit values rather than entire numbers. Like we can also say it is going to operate on the units, tens, hundreds, etc. levels. Gradually, it is going to refine the sorting process. So here we can say we are focusing on the digit sorting instead of entire number comparison. So that's how we are avoiding the comparison between all the numbers, and that's how we are saving the time. So what is its algorithm? So we'll see with a given array we are going to find the maximum number, and then from that number we are going to get the number of digits from that largest element. So from that digits, based on the number of digits, we are going to do those number of iterations, and then according to it we are going to sort the digits using the counting sort. So next we'll see with the sample array how it works. So these are the elements: 181, 289, 390, 121, 145, 736, 514 and 212. So these are the elements. So from this, first we are going to identify the maximum element or largest element. So here it is 736, which has 3 digits. So now we are going to iterate 3 times. Okay, so from that it is 0th position, 10th position and the 100th position. So here we require 3 iterations. So in the first iteration we are going to sort the digits on the 0th place. Okay, so here it is identified with the red color box. You can see 190. So now we are going to sort these digits, and accordingly we are going to place these elements. Okay, so we can see 0th is there, that is 390, so that is mapped to 0th, and then 121 and 181, so those are placed in the first index, and similarly 212, so that is going to second index. So there is no number with 3, so that's the reason it is blank. And then 4 we can say 514, and 5 it is 145, 736 it's, so 7 and 8 there are no numbers, so that's the reason it is blank. And then 9th position, so you can see 289. So in the iteration 1 we have sorted the numbers based on the digits. Okay, so next for second so these are the positions of the numbers after the first iteration. So 390, 181, 121 and 289. So in the second iteration we are going to do the comparison in the 10th position. Okay, so you can say the middle element. So now we are going to sort the middle elements. Okay, so from 0 to 9. Okay, so here we can see there is no number with 0, and then if you see number 1, so it is 212 and the 514. So those 2 elements we kept in the first position, and then 121, so we moved it to second position, and then 736 it is third, and 145 it is 4. There is no 5, 6, 7. Okay, next we have 181 and 289, and finally we have the 9th 390. So that's how we place the elements after the second iterations. Okay, so now this is the order: 212, 514, 121, 736, 145, 181, 289 and 390. So this is the order. in the third iteration we are going to do the comparison on the 100th place. So you can see it is identified red color, so 2 5 1 7 1 1 2 3. So now we are going to sort based on these positions. So first it is 0, that thing, and then we move to 1. So there are 3 numbers, 121 145 181, and then second 2 it is 212, and then 289, and similarly 390, and similarly with 4 there is no number, 5 514, and there is no element with 6, and next 736. So now you can see, so numbers by the third iteration you can see numbers are already sorted. So 121 145 181 212 289, so like this. So after third iteration, so this is the order, and we can see 736 elements are placed in the ascending order. Yeah, now we'll see the time complexity and the space complexity. So best case is like no sorting is required. For that it is the order of n plus k. So similarly average case, so elements are in jumbled order, so in that case like complexity will be order of nk. So even during the worst case, so the time complexity is order of nk. So here we can see we are doing the comparison between the digits rather than number, and space complexity also it is like order of n plus k. So now we'll see with the Java implementation, like how can we implement this Radix Sort algorithm. Okay. So now we can see, so this is the sample example. So now we created one class, so it has the array elements. Okay, so we have given the array like this, and then we are getting the length of this array, and then we are creating an object for this class Radix Sort demo, and then we are just printing the elements before sorting. So by using this print array method, so inside this we are just iterating the array and then printing the elements, and then we are calling this Radix Sort method. So and finally after just putting this statement and then again printing the elements. So coming to Radix Sort, so first we need to get the maximum element from the array. So for that we are doing this get max. So we are iterating the array, and then we are getting the maximum element from the array. So we are doing comparison with each number, and then that's how we are getting the maximum number. And then yeah, so and then we need to get the number of digits in the maximum number. So for that, so we are starting with iter 1 and max by iter 1 if it is greater than 0, and then we are incrementing it with into 10. So our comparison has to shift from 0th place to 10th place, and then 100th place, like that. So for that we are doing this, and then inside this we are doing the counting sort. So and again we are creating another method. So here we have created two arrays, output array and the count array. So count array, so as we seen in the slide, from 0th to 9th position. So for that tracking purpose, like we are creating this array, and this is the output array. And then first we need to count the elements. Okay, so count of array of I iteration plus percentage 10, and we are getting the count of numbers. Okay, and then we are getting the frequency of numbers, like how many numbers will be placed in that particular output array. Okay, and then we are going to place the elements in the sorted order, and that's how we are assigning this array. Okay, so first we'll execute it. Okay, So here this is the before sorting elements, and this is after sorting. So first number is 234 and then 91 858. So if you want to see like what is happening in the each iteration, how many iterations or something like that, then we can use that. Okay, so yeah, for each iteration we'll see like how the elements are changing its positions. So we'll see that. Yeah, so these are the elements before sorting, and in first iteration we can see first it will sort the digits based on the 0th place. Okay, 0 1 1 2, there is no ending with 3 4 5 6 8 and then 9. So this is how, and then in second iteration we are going to do the comparison on the 10th place. Okay, so yeah, so you can see like 2, so there is no element, so 2, and then 0 1, there is no 2 3 4, there is no 4 5 5 5 6 and then 9. And then third iteration, so we need to do for the 100th position, so 100th place, so that is 2 3, so there is no elements, right? So 0 0 0, so those were nothing will be there, so there is no element starting with 0, and then we have 1 115 and then 151, after that 259 360 and then 760 and then 858. So like this, if we are given that 4-digit number, and so it will go to the 1000th position. So like that we can do the implementation. So this is how we'll do this Radix Sort algorithm, and yeah, thank you so much for watching the video.